Good morning, students. So today let us discuss with the addition of Grignard reagent. So in the previous classes we have discussed what happens when an HCN as well as sodium bisulfite is added to an aldehyde as well as or a ketone. So we have discussed with the nucleophilic addition reaction. So after that, in today's class, let us continue the discussion with addition of Grignard reagent to an aldehyde or a ketone. So already we have discussed this concept with reference to the chapter alcohols, phenols and ethers. So with reference to alcohols, phenols and ethers, we have studied that whenever an aldehyde, that is HCHO, which is a formaldehyde, whenever a formaldehyde is added with Grignard reagent, that is RMgX, in the presence of ether medium, the product is always a primary alcohol. And when we take acetaldehyde, means aldehyde, in this you can take any aldehyde except formaldehyde. So except formaldehyde, if you take any aldehyde, when an aldehyde is made to react with a Grignard reagent in the presence of ether medium, you are going to get a secondary alcohol. In the same way, when we consider a ketone, any ketone, when it is made to react with a Grignard reagent in the presence of ether medium, the alcohol which is again obtained is an 3-degree alcohol or a tertiary alcohol. So already we have discussed this preparation of primary, secondary and tertiary alcohol in the chapter alcohols, phenols and ethers. So today let us discuss a general reaction. What happens when a Grignard reagent is added to an aldehyde or a ketone. So let us consider the general formula, that is RC double bond O R dash. Either it can be an aldehyde or it can be a ketone. So when this aldehyde or ketone is added with Grignard reagent, so to differentiate R from R dash, I will take this as R double dash. When the reaction takes place in the presence of dry ether medium, we know that Grignard reagent ionizes as R minus and MgX plus. When this R minus attacks to carbonyl carbon of an aldehyde or a ketone, so this electron will shift here, so that oxygen will become negatively charged. So this negatively charged oxygen takes away MgX, such that the addition product can be written as, so this is R, R dash, R double dash binded with oxygen with MgX. So this is known as an addition product, or this addition product can also be called as adduct. So adduct means it is nothing but an addition product. When this addition product or adduct is subjected to acid hydrolysis, so when it is subjected to acid hydrolysis, oxygen takes away the bond pair of electron towards itself, such that H plus will bind here, OH minus will take away Mg, so that I can write the product as C with R, with R, with R dash, with R double dash, along with OH, which is nothing but an alcohol, along with the formation of magnesium hydroxy halide. So this is the method how an Grignard reagent is added with either an aldehyde or a ketone. So after discussing this particular reaction, that is addition of Grignard reagent to an aldehyde or a ketone, now let us discuss what happens when an alcohol is added to an aldehyde. When we study with addition of alcohol to an aldehyde, here alcohol is added to an aldehyde in the presence of dry HCl, such that it gives rise to an intermediate called as hemiacetal. So this hemiacetal is again made to react with one more molecule of an alcohol in the presence of dry HCl, which gives rise to acetals as the major product. So now let us discuss how this particular chemical reaction takes place. So since it is particular with an aldehyde, I can write it as C double bond O single bond H with an aldehyde group along with an alkyl. So when an aldehyde is made to react with alcohol, so the reaction takes place or the addition takes place in the presence of what? Dry HCl. We know that this particular alcohol ionizes as R plus as well as OH minus. So we know this. So when this particular OH minus, that is hydroxyl group, attacks to carbonyl carbon of an aldehyde, migration of pi electrons takes place on oxygen. Oxygen becomes negative. Negatively charged oxygen will take away R plus, so that I can write it as C. I can write this as C with single bond R with H. So O minus has taken away R. I can write it as OR along with OH. So this particular intermediate which is obtained is called as hemiacetal. So there is one more name for this hemiacetal. This hemiacetal can also be called as, check here. So OR group is called as an alkoxy group. So this is an alcohol. I can also call it as alkoxy alcohol. Means hemiacetal or alkoxy alcohol, both are same. When this hemiacetal is again made to react with one more molecule of an alcohol, that is ROH, means this hemiacetal is again reacted with second molecule of an alcohol, where the reaction again takes place in the presence of dry HCl. Means reaction takes place in the presence of dry HCl. Again, this ROH ionizes as what? R plus as well as OH minus. Here, one we can notice that in an hemiacetal, oxygen is more electronegative, such that this hydrogen gets eliminated as a proton. When this hydrogen eliminates as a proton, oxygen becomes electron rich. Then this OH minus can easily capture away this H plus, so that water molecule gets eliminated. So when this water molecule gets eliminated, it is left out with R plus. So this R plus can attack or bind with negative oxygen atom, so that the product can be written as with R, with H, already with one OR, another with OR, so that this particular product which is obtained is called as acetal. So since this acetal contains two alkoxy groups present in it, hence I can also call it as dialkoxy. This is called as dialkoxy alkanes. Now a question comes. So dialkoxy means 2 times of OR. Why this alkane means? So this is carbon, alkyl group. So everything will be saturated. So since it is the general alkyl represented, hence it can be written as alkanes. So this is the particular reaction when an alcohol is added to an aldehyde, such that it gives hemiacetal as an intermediate. Further, this hemiacetal, upon reaction with second molecule of an alcohol in the presence of dry HCl, it loses water molecule along with the formation of acetals, which is also known as dialkoxy alkanes. When we study with a particular example, so let us consider acetaldehyde as an particular example, that is CH3CHO. When this acetaldehyde is added with ethyl alcohol C2H5OH in the presence of dry HCl. So acetaldehyde added with ethyl alcohol in the presence of dry HCl. So we know that it ionizes as C2H5 plus as well as OH minus. So this OH minus will attack the carbonyl carbon of an aldehyde, so that migration of electron take place on oxygen. Oxygen becomes negative. Negatively charged oxygen will take away C2H5 plus, so that I can write it as carbon binded with methyl with one hydrogen with O C2H5 along with OH. So in general it is called as what? Hemiacetal. So this hemiacetal is given by a particular name. So check here, this is first carbon, this is second carbon, longest chain is 2. So this is 1 ethoxy according to alphabetical. one ethoxy, one hydroxy, meth plus eth means 2 carbons, hence it is called as ethane. I can call this as one ethoxy, one hydroxy, one ethoxy, one hydroxy ethane as the name. This is the name of hemiacetal. So when this hemiacetal is again made to react with second molecule of ethyl alcohol, that is C2H5OH, and the reaction takes place again in the presence of what? In the presence of dry HCl. So here oxygen is electronegative in its nature. Here hydrogen gets eliminated as a proton. So this ionizes as C2H5 plus and OH minus, so that this OH minus will combine with H plus to eliminate what? Water molecule, so that what we can obtain as the major product. So carbon with CH3 with H, already there is OC2H5, and this O minus will take away C2H5 to form one more OC2H5, which is known as ethoxy group. Hence the name of the compound is called as, so this is the first carbon, this is ethoxy group, this is also ethoxy group, which is called as what? Diethoxy. Hence I can call it as diethoxy ethane as the major product. So this is the particular reaction when an alcohol is added to an aldehyde.